Hey, welcome to another adventure in old code. Well, it's as I promised. It's episode 59, and that means we are going to do a lot of these small programs in rapid succession and see if we can have some sort of fun with them. If not, we'll use them up because they have to be used up. So the small programs are all in here, and I've removed all the files that don't really make any sense. Like we had a laser game small, but we finished laser game. We had stock simulator small, but those programs, while they're small, they kind of belong with stock simulator, so I didn't want to do them. So we have the arrays folder, the dumb folder, the games folder, and the quick basic folder. So I'm not sure what to do. I think we'll just, for this first one, let's have some fun and do the quick basic small. There are 317 small programs in quick basic folder. So we are just going to start with the first one and go as far as we can. So let us do what is called crack, and I'll just put an asterisk beside the name because I don't have any program that correctly interprets these files. So we'll do it the old-fashioned way. Okay, we are looking up crack. Okay, so for each one of these small programs, we'll run it, we'll see it, we'll go through it. They're all small. And so we'll try and determine who wrote it, why they wrote it, was it used elsewhere, in any historical memories I have of such programs. Okay, let's begin. Crack. A crack is forming on the screen. This is kind of like Brownian motion too. Ooh, there's a sigma. Spot the sigma. And I'm guessing at times I don't see it drawing because it's drawing back on itself and it's gone past the screen. Okay, 42, 43, 44, will this ever end? I don't know. See, we're sleeping for one here. Let's not sleep at all. Whoa, it just flew off the screen. Whoa, this is cool. It just doesn't have any bounds checks to stay on the screen. So you get a brand new pattern every time. That's cool. And it goes up to 100. Okay, let's peruse it and see what we can see. Crack. Okay, random number generator. Randomize the timer. These tabs are all out of whack here. So X is a random number between 620. Y is a random number between 1 and 480. This is a random coordinate, but we're not drawing to the very edge of the right hand of the screen. Remember, we have 640 across the x-axis. So we're giving a bit of a buffer on the right side, and we're p-setting, putting a pixel. Color 6 is that orange, beautiful color. And so this just starts off with a random dot on the screen. And then for each crack, okay, we're gonna print the number that we've currently drawn up at the top left at 1, 1. And D equals FNR 16. So this is clearly direction. Direction is a random number between 1 and 16, and so there are 16 different directions. And this is how we do it. Not really 16 different directions. You recall that the draw command takes a letter, up, down, left, right, E, F, G, or H. So up, down, left, and right is very self-explanatory. E, F, G, and H, maybe they'll give us a nice you going to give us a nice thing to look at? Nope. E, F, G, and H. So E moves up and to the right, so it starts, you know, sort of at the 2 o'clock position. F is down and to the right, so this is going to move clockwise, E, F, G, and H. So we can even draw, and I think my brother used to draw this. We can draw this up, E, right, F, down, G, H, hey, hey. No, this is L. Oh, what am I doing? H. There. You kind of get the idea. That's kind of what we're doing. Whatever. Forget it. Okay, never again. So this is just gonna, so if 1 and 8, it seems to pick a random one of those 8 directions and draws 40 pixels. If it's 9 to 16, it again corresponds to one of those 8 directions. It's just a farther drawing. So it could randomly go 40 or 65 pixels in any one of the 8 directions, and it just happens. It just goes. Cool. All right. Well, I don't know who wrote this. Perhaps it was me. I know my brother used to put that graphic, the directional graphic in his text for reference. Why did they write this? I think it was just cool, experimenting with the draw command. This has gone off the screen. Okay, so that is crack. I'm not sure who wrote this. I'm going to say it was me. I'm also not sure why we didn't go to the edge of the screen. Okay, the only thing I can do is I can actually center this crack starting at 240. So he'll always start in the middle of the screen here. Oh, right, the sleep command, you can just hold a button and it skips the time. Okay, anyway, that's crack. Let's move on. Okay, small, ugh. I need to find a better system for this. Okay, that's crack. Let's do plane. 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 Ah, see, this is my brother's program. He's done this. Oh, and he was smart enough to put them in comments so the compiler wouldn't give him problems. Okay, beautiful. I suspect this is his drawing of a plane for one of his games. Because when you have a game and you want to make a ship, you don't make the ship in the program you're writing. You just write a new program just to make the ship and then copy the code. That's all. This is a bunch of lines with a draw command. So we can I'm not sure. Yeah, we'll just put sleeps after all of them. Just for kicks. It's the only interesting thing I can think to do with this program, just so we can watch it. So that had to be a draw. Sometimes he can use lines, sometimes he has to use the draw command. And the box around it is he's put a box around it, I imagine, because in the actual program, this line command is going to be replaced with a get command, which will grab it as a stamp, an image stamp. But the coordinate system is still the same. So you draw the box to see what visually what is going to get included in your get command. So that is plain. Awesome. Perfect. I should have looked at the next one. Ay, ay, ay. Bear with me, folks. This is clearly something I'm going to have to fix. That is plain. What are we at? 10 minutes here? No. Now we're going to do missile. Okay. Oh, let's write these down. Missile, laser. Let's remember missile and laser. We'll try and get through them both. Okay. Missile. I'm assuming this was again for one game. That is really, really small. But that's a missile, folks. I don't know how we can make that bigger. I don't think we can. I mean, I could. No, that would make too much work. This is drawing the missile. Probably that comes out of that ship. Pretty cool missile. Couple of pieces, drawing, and then draw the line. Okay, that's plain. That's missile. Let's go to laser. Laser. I'm beginning to. Oh boy, these are all for games. Okay, draw the circle in gray, paint it gray. Draw some lines for that pie shape and paint. So, okay, that's great. Laser in all of its glory. Again, my brother's thing for one of his games. Awesome. Kate, what's next? Binary 0, 1, binary no, binary 10. I'm going to write this down. Binary 0, 1, binary no, and binary 10. And if we have a chance, we'll do the one with the 2 exclamation marks. AS and then DEC. All right, let's do it. These should be something different. Binary. Binary 0, 1. Let's do it. Sweet. Enter a number in binary system. Okay, I did. Oh, actually, can I? No. What? Well, I probably have to. Okay, enter a number in binary system. All right. And I have to make sure to get it 2, 4, 8, 16, 1, 1, 1, 1, 1. Enter. What the heck? What's it doing? One, 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 one. Where's my number? Okay. Dir string tells me it's my brother's program. We're allowing for 8 inputs. So input string 1. Oh, and the input string command. Yeah, we know that's my brother's too. So grab grab a keyboard input. If it's not 1 and not 0, then end. So you actually don't get a chance to do anything. That's why it was ending, because it's wanting 8 characters. Okay, so if I go 1, 2, 3, 4, 5, 6, 7, 8. Ha! Yes, folks. 31. I try and make it come up every time. That is cool. Okay, so it asks for 8 bits basically, and it's going to convert that 8-bit number into a decimal value. So after this if statement, if we're still running the program, we're guaranteed it's 1 or 0. Okay, so we turn it into its value using the val commands. This will actually be the number 1 or the number 0. And then we do this. How do we convert from binary to decimal? Well, whereas the decimal system, starting from the right, is your ones column, and then your tens column, and then your hundreds column. Binary, it's all based on 2. So you start with your ones column, then you have your twos column, and then your fours column, and then your eights column. And so if B is equal to 1, then E is 120. Oh, okay. So because you're typing from the right or from the left-hand side, the most significant digit is going to be the first thing you type. So if you typed a 1 to start out with, then that stands for 128 in the decimal system. If you typed a 0, then this is just keeping track of, okay. This is keeping track of what you need to add to the decimal number in order to actually make it your actual number. So this is him trying to figure out which value to use, because then we're going to take your number and we're going to add to it dir times this number thing that we're figuring out. So yeah, if dir was 0, your number becomes unchanged. If dir was 1, then we're going to add the value E to it. And E is based on which bit this is. So this could have all been replaced with E equals 2 to the power of 8. No? Oh, right. Basic. 2 to the power of B. That's all he's trying to figure out. Whoops, I'm wrong. B minus 1. Yes, because that is based on, okay, 1, 2, 3. Oh, no, because I'm going, oh boy. This could have been 8 to 1, step minus 1. Because we're starting out with the most significant one first. Okay, so there are very different ways that we could do this, but okay, that's it. That's binary 0, 1. Let's take a look at binary no. Binary no. I'm sure all of these are going to be very similar. So we understand what he's doing here now. Okay, let's run this. Oh, sweet. This is him just writing binary numbers in sequential order. If you don't understand how binary works, we're not really going to teach you here. I assume you know. So the way he's going to 255, dir equals B list. Okay. So dir is the number that he's trying to convert into binary. Actually, wait a second. Dir is greater. If dir is greater than or equal to e, then print 1, and dir is dir minus e. So this is how, okay, because before we converted binary into decimal. This is him converting decimal into binary. So instead of adding, we're going to be subtracting from the number. So if dir is greater than e, yeah. So if he's greater than 128, he's going to have a 1 in the first space. Okay, and if he's less than, he's going to have a 0. And that's what he's figuring out here. And that's how you do the conversion. Cool. And then we print some spaces, followed by the actual number that we're converting, and we're waiting. So that's cool. That is a way to convert from binary to decimal, or decimal to binary. So we went from binary to decimal and decimal to binary. Okay, now we're going to look at binary 1, 0. Number 31. And this is going, okay, so this is backwards. This is the backwards of the first binary program. So this may have been written first, I don't know. And then that binary no, which loops through all the numbers 0 to 255. So this is the same logic that we just had before. All right, so I can I do 512? See, this is because he's assuming he's only using 8 bits, so he can only represent numbers between 0 and 255. So anything greater than 255 is going to be written as all ones, because you need more than 8 bits to represent these numbers, but he's only got 8 bits, and so they're all 1, 1, 1, 1, 1. But this is cool. I mean, I can, what's 67? 0, 1, 0, 0, 0, 0, 1, 1. What's 10? This is my favorite. 10 is 10, 10. All right, very cool. So that is binary 1, 0, which maybe that's binary 2. Okay, binary exclamation mark, whoa. Okay, that's cool. This interesting. So he's doing the same thing. He's going from 0 to 255 and calculating the binary, converting it into binary. If it's greater than or equal to E, then color. Oh, this is interesting. This is the first instance here in Adventures in Old Code that I've seen the color command with 2 colors. Now what this does is the foreground and the background. So when there's a second color on the color statement, it actually changes the background color. So this is him. So if it's a 1, basically it'll be red on a blue background. And if it's 0, it will be green on a bright blue background. It's the same. Why is that background? This is this. So 1s are red and 0s are green. Why didn't the curious thing here is that why is this color and the background not it doesn't seem to be corresponding to the actual colors. The zeros actually have a background color of 9, and the ones have a background color of 1. But they all show as the same thing. So what about this background color? I don't understand. Background is the screen color, but you only get from 0 to 7. So 9 would actually, I guess it's subtracting 7 from the 9. So 8 would be the same color as color 0, 9 would be the same color as color 1, and so on and so forth. No, you can even have a border surrounding the screen. I never think I used that. Okay, anyway, I don't, that was commented out. What does that do? Oh, interesting. Okay. So because he's not doing anything with, because he's got print semicolons after each print statement, he's just always staying on the same line. So this just wraps around and fills the screen with ones and zeros. Okay, perfect. Binary as. Binary as. Type a message. I am so awesome. Whoops. Do you think so? Okay, now tilde to quit. Sweet. So he's taken each character and converted it to its binary representation. So 8 bits defines a number between 0 and 255, and it's no coincidence that the ASCII character code is 256 characters from 0 to 255. Each character in the ASCII character code is represented by a unique 8-bit number. And so we can easily go through and convert these things. So he grabs the input, he converts it to its ASCII number, the actual number. So if you typed in a capital A, for instance, this would actually be 65. And he needs it to be an actual number because he's going to be doing his decimal to binary conversion here. Okay, as long as it's not a tilde, then print that to the screen. And that's why we were getting that, you know, when I hit backspace, I got that funky block. He's not doing anything, just grab whatever you input, spit it to the screen, as long as it's not a tilde. Now, if it's not a tilde, then he's going to take that number, that value, and convert it into decimal. That's what he's doing here. Except he's not printing the ones and zeros to a screen. He's concatenating them onto a code. So he can build up this code. And then the code is a string. The code is a string, and so what he's doing is build up the 8 values for the ones and zeros for the current thing you've typed. And then tack on 2 spaces and end if. And so this code is actually, it looks like, oh, tilde to quit. It looks like, you know, a lot of different words, but this is all one long string separated by spaces. So that's how he did that. That is cool. Okay, and then loop until, yeah, dir string equals tilde, and then prints the code. Okay, that's cool. We are almost at a half an hour here. We've got one more, binary des. Let's see if we can squeeze that in. Oh, was it bin to des? Okay. This is probably the same thing. Enter a number in the binary system. 0, 0, 0, 1, 1, 1, 1, 1. That's the same thing as before. This is a direct copy of binary 0, 1. And again, 1 to 8. So he will only accept 8 characters. 1, 2, 3, 4, 5, 6, 7, 8. 255. There you go. Okay, that I think concludes that all. That's a lot of stuff we got through. Great. Okay, thanks for joining me in this adventure in Old Code. Have a nice day, and we will see you next time.